Alright, so we're going to start where we left off in our notes, 9.7, Law of Sines and Cosines. So, the purpose of these two, Law of Sines, Law of Cosines, is for non-right triangles. Right? So, acute and obtuse we're looking at. We learned the Law of Sines yesterday. Okay, a Law of Sines, you set up a proportion, and it could look like A over sine of angle A. And it could be equal to B over sine of angle B. Or you could flip it, where you could have sine of angle A over side A equals sine of angle B over side B. So, what mattered was you had corresponding parts on the top and the bottom. So A and A, B and B. And the top stayed the same. So these are both side lengths, and these are both sine of an angle. These are both sine of an angle, and these are side lengths. Remember, to figure out which one to use, you put the missing value, or the missing piece, however you want to say it, you're going to put it in the top. It just makes your life easier. Right? So we also learned which theorems to use it for, and which cases, I guess, is the best way to say it, which cases to use it for. So there was like angle, side, angle, which looked like knowing an angle, 40, knowing a side, and knowing an angle. Okay, the reason that this works, your whole goal, or I guess the best way to put it, you use the law of sines whenever you have a known pair. And remember, a known pair is an opposite side and angle, or a corresponding side and angle, if you will. So, knowing side A and angle A, or knowing side B and angle B, or knowing side C and angle C, whatever works. So the reason that this one would is because we could very easily find this angle, and it would be a known pair. You'd have 8 and that angle. The reason is, we got 40 and 60, which is 80. Subtract that from 180, and this angle would be 100. So you would use these two to set up a proportion to solve for a missing side length. We also have angle, angle, side. Very similar idea, where you've got two angles, and then the side is not included. But this one's even simpler because you already have a known pair, and it'd be 8 and 40. But again, you would very easily find that missing angle. Last is knowing side, side, angle. So knowing a side and an angle. So the reason, again, is because you would have a corresponding side and angle. So you'd have a known pair. You'd be able to use the law of sines. But what happens when you don't have a known pair? We're going to learn about side, 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 which is where you know all the side lengths. So obviously there's no known pair. There's not an angle. And then also for side, angle, side, which would be like this, where you know a side, an angle, and a side. There's no known pair. So that is the purpose for the law of cosine. But before we get into the law of cosine, we're going to use the law of sine in our next example. A surveyor makes the measurements shown to determine the length of the bridge to be built across a small lake from the north picnic area to the south picnic area. So from north to the south, we're building a bridge. We want to find the length, which is kind of marked as C. So the first thing you want to ask yourself is, do we have a known pair? Okay. At first, it looks like we don't. We have A and 71, but we have 150, and we can find this angle, because we know 71 plus 60 is 131. Subtract that from 180. And our missing angle is 49. So that means we've got a known pair. I've highlighted that in red. And then we can find the length we need to find using 60 degrees. So we're going to set up a proportion using the law of sine. Side C over sine of 60, and we're going to set it equal to 150 over sine of 49 degrees. So again, the reason you want that missing value in the top is because all I have to do to get it by itself is multiply both sides by a sine of 60. And then we get, so 150 over sine of 49 times sine of 60. We get 172. It doesn't say what to round to, but we can round to the 10th. 172.1, and it is meters. Okay, so that's the law of sines. Let's talk about the law of cosines. So the law of cosines is used when you don't have a known pair. Okay, so in the cases of side angle, side, and side, side, side. So if you look, there's 3 formulas, and it can look overwhelming at first, but you will recognize the pattern. Okay, so the purpose of the law of sines, you will only use it one time in a problem. The purpose of the law of sines is to find a known pair. Once we find a known pair, then we will use the law of sine. So you'll use the law of sine probably 9 out of 10 times, and you'll use the law of cosine, 1 out of 10 times. You'll use it the first step, and then after that you would use the law of sine to solve for the rest of the triangle. So there are 3 formulas, and they all have the same pattern. Okay, remember that lowercase letters represent sides, and uppercase letters represent angles. Okay, so let's look at this. And yep, you use this to establish a known pair. That is our goal. We want an angle and the side opposite of it. So here's how we do that. A squared plus b squared plus c squared minus 2bc times cosine of angle A. So it looks a little overwhelming at first, but you've seen a, b, and c squared, right? It looks like the Pythagorean theorem. And then the pattern is minus 2bc, so whatever these 2 letters are, it's going to be here. And then cosine of angle A, which matches the side there. So you'll know the pattern for the next one is b squared equals a squared plus c squared minus 2ac cosine of b. And then last would be c squared equals a squared plus b squared minus 2 times ab cosine of angle C. So, Ms. Marshall, how do I know which one to use? Here is how you will know. You will pick A, B, or C based on your missing or your given angle. So whatever angle you're looking for, if I'm looking for angle B, I'm going to use the b squared formula. If I'm looking for angle A, I'm going to use the a squared formula. If I'm looking for C, I'll use the c squared formula. And the same thing if you're given it. Okay? So, let's practice. Solve the right triangle. Okay? So the reason we can't use the law of sine is because we don't have a known pair. We have an angle, well, we've got a side, an angle, and a side. I don't know the angle across from 14, I don't know the side across from 34, I don't know the angle across from 11. So I don't have a known pair, I'm going to use the law of cosines. Remember that solve the triangle means to find all the missing sides and all the missing angles. So, we are given angle B, so we are going to use the b squared formula. B squared equals a squared plus c squared minus 2ac, AC, cosine of angle B. We're going to use this formula and we're going to end up finding the side length of B. And then when we do, we'll have a known pair and we will use the law of sines. But we're getting ahead of ourselves. Let's plug things in. I don't know B. I know A is across from angle A. A is 11. And C is across from angle C. So C is 14 minus 2 times 11 times 14 cosine of angle B. And angle B is 34. The beautiful thing of this is we type in this entire right side. We know all of the values. You have a scientific calculator. So 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. So here is the thing. Remember to not clear your calculator. Don't clear it. I'm going to write down what you should be seeing, 61.656427765. We want to get B by itself. So remember, your calculator can remember numbers. So you're going to hit square root of previous answer. So square root previous answer, that is next to the equal sign. And you will get 8.5. If we're rounding to the 10th, it's 7.9. Here is the thing. Our final answer will be rounded to 7.9. However, when we go to use this, remember how many times I say don't use a rounded number in your answer, or don't use a rounded number in the middle of a problem. So when you use a rounded number in the middle of a problem and then you round again, or you square it, or you square root it, or you add it with something or whatever, and then you round at the end, you're going to be very off from the answer. So whenever we go to use it in a second in the law of sines, I would not use the rounded version, as annoying as it is to use this big old long decimal. You will get the exact answer instead of being off. So again, in your answer box, you're going to round it like it says. But your textbook, what it does, if you look, is it actually leaves that in the fraction. That's a hot mess. We're not going to do that. We're going to use the whole decimal instead. If you don't know what I'm talking about, you can always look in the textbook at this example, and it's a sight to see. So why did we do that? Now we have a known pair. We know this side length, and we know 34. So what we can do is find missing angles. It does matter the order to go in. So if you look next to this question, it says like special note or something. Here's what you need to know. The inverse, or sines inverse, I guess would be the best way to say it. Sines inverse only does acute angles. So sines inverse only does acute angles. Why does that matter to me, Mrs. Marshall? Why? Angle C is obtuse. It's barely obtuse, but it is obtuse nonetheless. If you try to use the law of sines to find this obtuse angle, it will not work because we would have sine of C, and eventually we would do the inverse of sine to find angle C. But sine can only do acute angles. The inverse of sine can only do acute angles. It cannot do obtuse. I can't really explain to you why. It is just a rule, and we can't use that. So here's what we're going to do instead. Since we can't use the inverse of sine, or we can't use it for obtuse angles, of course. Angle A is acute. So if we find angle A and we know angle B, we know the three angles in a triangle add up to 180, and we could find angle C. Okay, so you have to find the acute angle here. So we're going to find A. So A, using A inside A, so we're going to say sine of angle A, because you want what's missing in the numerator, over side A, which is 11, equals sine of angle 34, over, remember this, we don't want to use the rounded version, so 7.8521607. And you're like, I hate that. That's okay. You're going to type it in your calculator from here. We're going to multiply times 11. So we're going to do fraction, sine of 34 over 7.8521607 times 11. In your calculator, you'll have sine of angle A equals 0.783366792. We're going to hit the shift button, shift sign to find an angle. Remember, you can type in previous answer, so you don't have to type in the decimal. This is the final answer for our angle, and it's 51.6. So the measure of angle would be just fine. A is 51.6. So at this point, we can find the measure of angle C by adding 34 and 51.6 and subtracting from 180. So we'd get 94.4. So again, make sure you read that special note. Here's how it reads in your textbook. In example 6, the smaller remaining angle is found first because the inverse sine feature of a calculator only gives angle measures from 0 to 90. So when an angle is obtuse, like angle C, because 14 squared is greater than 7.8 squared, it's using the Pythagorean theorem, if you remember, the Pythagorean theorem to decide what kind of triangle it is. But you could also just line up a piece of paper and see that, what a right angle looks like, and it's more than a right angle. So you won't get the correct angle measure if you found this angle first. So you got to find the acute angle first, and then subtract from 180. So that's a special rule here. For the next example, there is also a special rule, but it's a little less complicated. So again, you can't use the sine button for an obtuse angle. So what you need to do here, there is an obtuse angle. You need to find the angle across from the longest side first. So here's what it reads. In example 7, the largest angle is found first to make sure that the other two angles are acute. This way, when you use the law of sines, again, you can't use the inverse of sine with an obtuse angle. So we find this angle at B first, okay, because the remaining two are acute, and we could use the law of sines with them. The easiest way to find that is just pick the longest side and find the angle across from it. Okay, so we're going to be looking for angle B. So we're going to use the B squared formula. B squared equals A squared plus C squared minus 2AC, cosine of angle B. So here's a little different because we do know the length of B. B is 27. And A, where's A? A is across from angle A, so A is 12. And C is 20. So minus 2 times 12 times 20, and then cosine of B. You want to make sure you're not working ahead of me right now because I'm going to teach you what the most common mistake is. So you can do 27 squared. It is 729. Go ahead and type in both of these, but not all of the numbers. I'll show you why. 12 squared is 144, and 20 squared is 400. Add them together. You could have already typed that in your calculator. It's 544. I lied. No, I didn't. That was very truthful. I'm sorry. I doubted myself for a second. It's 544. You are now going to multiply these together. Ms. Marshall, why are you being particular? I'm not. I'm mathing. I hope that you're mathing as well. Multiply those together and you get 480 cosine of B. So here's what you need to recognize. This number and cosine of b, all of these numbers and cosine of b, they're being multiplied. So think about if this equation looked like 729 equals 544 minus 480x. Think about if x was here instead of cosine of b. You know, after years of algebra, you cannot combine these because they are not like terms. This is an x and this is a number. We have the same thing going on here, where we have cosine of b attached. So we need to move this guy, the 544, we need to move it over by subtraction. So subtract 544 on both sides. You get 185. And it equals negative 480 cosine of b. So our goal is to get b by itself. In order to get b by itself, we need cosine of b by itself. And this negative 480 is multiplying by cosine. So we need to divide by negative 480. So what you need to make sure you do is pay attention to that negative. Because if you don't divide by the negative, you will get a completely different answer, and it will not be correct, obviously. So we're going to divide. I'm going to give myself a little more room. And by now you've gotten a negative decimal about negative 0.385416, and it says it's repeating. Okay, and it equals cosine of b. So to get b by itself, it's currently attached to cosine. To get rid of that, you're going to use the inverse of cosine of your previous answer, which is that ugly decimal. So shift cosine of your previous answer, and we're going to get 112.7 degrees. 112.7 degrees. So again, I would not round in the middle of a problem. So yes, in your final answer, you're going to write 112.7. But when you're using it in the law of cosine, or the law of sine in a second, I would make sure you do not round. So it's 0.6696099. I know that's ugly, but you will have the correct answer, which is beautiful. So now we have a known pair, and it's b and b. So we're going to use that to find the remaining angles. Okay, remember you want to make sure you have acute angles, and we've already taken care of the obtuse, so all that's left is acute. So now you just pick one. We're just going to pick A to stay in the same habit of picking the smaller angle first, just so you don't have to ask yourself, when do I do it and when do I not? Just do it all the time and you won't have to worry about it. So sine of angle A over side A, which is 12, we're going to set it equal to sine of our angle, 112.669699 over 27. Multiply times 12. Sine of angle A equals, go ahead and start typing into our calculator, a fraction, sine of 112.669699 over 27 times 12.410107845 shift sine to get my angle by itself, and we're going to get 24.2. So the measure of angle A is 24.2, which means we can very easily find the measure of that remaining angle of C by subtracting from 180. If we add these two, to 136.9, subtract that from 180, and we get 43.1. Boom. So remember, law of cosine, you use it once, and then you use the law of sine. Okay. The only special note on here, so remember that you got, it says special note or something like that. Find the obtuse angle first. Okay, because again, sine, the law of sine, you would use the inverse of sine, and it cannot find the measure of an obtuse angle, only acute. We will only do one more, and it is this first triangle. So do you have a known pair to use the law of sine? Do we have an angle and a side across from each other? We do not. So we have to use the law of cosine. Remember, use the law of cosine based on the angle you have. So we're going to do b squared equals a squared plus c squared minus 2ac cosine of angle b. We don't have b, but we do have a. A is across from angle A, and it's 45. C is across from angle C, and it is 43. Minus 2 times 45 times 43 cosine of 88 degrees. So remember, everything is filled in, so we can just type all of that in our calculator. 45 squared plus 43 squared minus 2 times 45 times 43 cosine of 88. What an ugly number. We get 3,738.93894.8. Take the square root of that on both sides. So you hit square root of previous answer. We get 61.1. Okay, just going off of what we've been talking about, in your final answer box, you can round. This is AC equals 61.1. But when we go to use this later on, I would not round. So we get the exact answer. So in the middle of the problem, don't round, so we can have an exact answer. Now we have a known pair. So we're going to use this known pair, we have a side and angle, to find other things. So remember, you want to find only acute angles with the law of sines, but they're both acute, so it really doesn't matter which one you pick. But just to stay in the habit of finding the smallest angle first, we can find C. So sine of C over 43 is equal to sine of 88 over 61. Let me see if I can read it. 1,468,6376 times 43 so sine of 88 in the numerator over 61 point, all that, times 43. You get something like 0.702796569. Hit shift sign of your previous answer. We get 44.7. So the measure of angle, what do we say? A? Nope, A? Nope, we're finding C. Sorry, measure of angle C equals 44.7. To find the remaining angle, we are going to subtract from 180. So 180 minus 88 and 44.7, which is 47.3 degrees. We will stop here so that you can try and practice.